In this video, we'll discuss the following points and learn some more advanced ways to use ellipses to make more complex shapes and manipulate moving parts on our designs. Make sure you spend 1 hour a day practicing the things you learn here until you can do them all. The link for this course's Anki deck is in the description, as well as a link to our Discord server, so that you can help test if this is an effective way to learn these skills compared to more traditional approaches. You've already seen that we can use circles and ellipses to rotate squares around, and that's a very useful trick to remember. But we can also slice and subdivide ellipses to measure and set alignments in our work. The way we do this is to just use an orthographic view. Let's say we want to make a huge cog in perspective. Planning where all those teeth will sit accurately would be very tough, and so our best bet is to work out all of this nicely on a perfect circle in orthographic view. Once we've done that, we can project the height of the circle across to the line where we want the cog to be placed, along with any of the other measurement marks that we have made. Note how the back edge of the cog and circle we are using to map this out are actually the same height. This is the easiest way to manage this projection method. It's still a huge pain to do, and it involves lots of messy lines. You're also highly recommended to use an ellipse template, which I did not do here. I don't have one big enough. By drawing from the center of the perspective cog out to where the points of each tooth are, we can generate the guidelines required to figure out exactly how this thing will work with all the foreshortening going on to a reasonable degree of accuracy. The furthest back side is far easier to plot because we can fire lines from the orthographic cog directly to the points they will be placed in perspective. We then have to fire these lines along the plane towards us in order to draw the other side of the cog, and that's the more difficult part. Once complete, we can then extrude this flat cog shape backwards or forwards into perspective. It's far from perfect, but I'm sure you get the idea. Another very common thing to draw with ellipses is vehicle wheels, and these are rarely just simple cylinders, often featuring complex rim and spoke designs. To handle these, we can use the same trick of designing the wheel in orthographic, but we also need to manage the depth of the design a little more carefully. For example, we might wish to make the wheel taper to the inside a little, or have more of a dish-shaped curve extruding from the surface. To manage the ends of the cylinders, we need to be able to offset ellipses. That means connecting planes up along the depth of the cylinder receding into perspective. This is actually pretty simple. You just use the axle for the ellipse, which remember is something we call the minor axis, to pull the surface inwards to wherever we want. This allows us to cut material out of the face of the cylinder, and we can use the same concept to bulge out the face of the cylinder too, making designs that project forward. It's easier to understand this by planning it out in an orthographic side view first. It takes a while to make these sometimes, and you'll likely end up with a lot of construction lines, so take it slowly and think carefully as you go. You'll need to ghost the design in to ensure that it's correctly working inside the volume. This is something I've taken directly from the Scott Robertson book, but it's actually another example of using geometry to make your life easier, and I learned a lot of this from studying origami. If we have a square or circle, which remember are basically the same thing, we can use a vertical line spanning its height to very quickly create a 5-point star, and this is useful for making wheel rims and other objects. We find the halfway line and divide everything above it into equal thirds. We then ping a line horizontally across the lowest mark we have made here. On the bottom half, we do the same thing, but this time we divide it up into quarters. Where the horizontal marks touch the outline of the circle, we can aim the arms of our stars to. This is another trick that works in any perspective, so it's pretty cool. As mentioned, a lot of these tricks are often used in origami, and so if you want to see some more of them for yourself, there's a really great book called Origami and Math, Simple to Complex by John Montroll. It's full of ways to turn a square into other more complex geometric shapes, and most of them work not only on physical paper sheets, but also in the squares you draw and design. The main thing to realize is that we can subdivide squares to create more complex polygons, and if we place a circle inside the square, well then it works for circles too. For example, let's say we want to make an equilateral triangle. These don't actually fit inside a square, so how do we figure out exactly how to make the triangle as perfect as possible in perspective? We can divide the square in half vertically, and then divide the lower half again, and once more. The crease line that this last fold would create is where we fire a line from the apex of the triangle to the edge of the paper. This crease line is actually the bottom edge of the triangle, and so we have to erase out that bottom strip. This is how we account for the fact that a triangle cannot fit inside a square. There are a lot of tricks like this, but you won't often see them in drawing books. You will often see them in origami books though, so it pays sometimes to have a broad range of hobbies and interests, and thinking about how you can take the things you know from fields you understand and see how they can be applied to the field of drawing. What about if you wanted to make a spiral staircase or similarly stepped circular design? Well, we can once again just use a circle or ellipse in plan view. that is projected onto the floor to map out the steps. From there, we project them upwards and use a subdivision of a vertical line to map out the step height and any gaps we want in between the treads. You can also use a construction plane off to the side to map out the height if you find that easier or cleaner. The hardest part of this is that each step has to have a different degree, as it moves upwards or downwards relative to our eye level. This means you'll have to very carefully pick the correct degree of ellipse for each individual step, which is a bit of a pain, but not that difficult if you've managed everything up to this point in the video series. The other wonderful use of circles is that we can use them to measure and map angles for the scene objects we make. For example, let's say we have just randomly designed this box with a sloped surface. The surface normal would be the line that we would draw out of the sloped plane, which is perfectly perpendicular to it. This makes more sense if we look at it from an orthographic side view. You can see how it works. The surface normal would be great to know because we can then use it to perfectly extrude things from the sloped surface. All we have to do here is work out which degree ellipse will sit nicely up in the corner there, with its center point exactly on the corner. From here, we can map the sloped line into the circle and measure the angle this creates from vertical. This wedge angle then needs to be translated across from vertical to horizontal. And once we've done that, we can successfully translate the angle of the slope to make it perpendicular to the face. This gives us the rough normal direction. Using it can be as simple as using the same parallel line we just worked out, but it's not always the case. Often we have to move the ellipse along to the middle of the volume in line with wherever we want to project out from, like the dead center of this box. If your image features any fisheyeing or a bit more convergence, then you have to work this out for each corner and average the results to find the correct line to use in the middle. I actually tend to find that after a while you get good enough, you don't even need to work this out. You can just use your knowledge of perspective to get good enough results. Once again, just ask yourself, does this look correct? And if you can't quite nail it, then you have these approaches to more accurately measure and fall back on. As a continuation of the last point, we can use the exact same approach to make movable parts on our drawings. If I draw a hippo and I want its jaws to open, I can use an ellipse with an angle on it to work out where the jaw would actually hinge to. I can also use an ellipse from the hinge point here to the jaw tip and use that to measure the exact angle the jaw would open out to. I can then build out the open jaw in perspective. This could be used to make things like opening treasure chests or cockpits or car doors or whatever else you want, and it's something that I use regularly. Making parts that really feel like they're opening and closing accurately is a cool way to boost the believability of your designs. All we do is draw a circle on the floor or wall aligned in such a way that the dead center is aligned to where the hinges would be. The diameter of this circle will be the same as the length of the opening panel, so the same size as the door or jaw or whatever else we want to open. From here we draw the circle out and just mark the angle where we want it to open to. We can then draw the open door or part along this new line in the correct perspective. You might have to draw quite a big circle for this, and even draw it on the floor and then project it along a bit to figure out exactly how the door or moving part would look and to see exactly where it will be placed in 3D space. Yet another use of this is wrapping graphics, but I have found that this trick, also featured in the Scott Robertson book, is less useful and less accurate. If we have a tin of beans and we want to wrap the label around it, we can draw the label out on a mapped construction plane placed here on the side of the tin. We can then use an ellipse to swing the tip of this label and any points we care about on the label around onto the tin. We can then draw the design onto the tin. It's actually exactly the same process as the door hinging one we just saw, just this time we're using it to map points onto a cylinder. The thing is, this method is really not that accurate, because you have to take into account the curvature of the cylinder that you're wrapping onto. Scott does this by literally just bringing the far edge that he swings around, along with any other measurements, back in a bit. You'll find that this does give good enough results, but the crazier your surface, the less accurate this is, and it's another example of something that nowadays would just quickly be done in a program like Photoshop using the transform tools. Still, it is a pretty useful thing to know, and it offers you another way to transfer designs you want to project onto surfaces, similar to what we covered in the previous video. And that's the final point I want to make here. You'll hopefully start to see that there are actually many ways to solve any of the issues you have while drawing now. You can mix and match everything you know so far and use whatever approach you feel you vibe with best to solve the problems that you face. While it's important to experiment with them all, I'm a firm believer that you should go with what works best for you and your learning style. Over time, you'll find you develop your own workflows for this to get faster and better results, measuring less and being able to just quickly create the things you want to see on the paper. From there, you just tighten them up and take them to a finished piece of art. Try out all of these little tricks and construction methods to see what you can use ellipses for. Can you make a cog? How about a spiral staircase or a car wheel? Can you find the surface normal of your sloped planes? Can you make flaps and doors and other hinged parts and open and close them in a realistic way? So to recap, you learned that we can subdivide ellipses to measure things, design things, and set angles for other parts of our work, and that this can be used for all sorts of things from projecting onto curved surfaces, to making parts open and close realistically, to building complex cylindrical forms. Make sure you can do the following before moving on to the next video. To make the challenge easier, just start out using these to make simple stuff. You can draw a box with a simple door on it. You can make a very simple cog or wheel design. Keep the convergence only slight. This will make the planes you work on closer to square and keep things easier. Then when you feel more confident, you can work on more foreshortened planes at more extreme perspectives. To make the challenge harder, try and make things that use all of these tricks to test them out. Can you make a bunch of cogs that feel like they really fit together? Can you make a dinosaur or other life form with a moving jaw? By this point, you've already caught me up in terms of all the stuff I know and have made notes on. You should now have all the knowledge required to make pretty much anything you can think of. It's just a case of using the knowledge in specific ways to really make it yours and see what you can do with it. That and putting in lots of hours of practice. But there's one more thing that I can't finish this series without covering, and that's 5-point perspective. So that's what we'll look at next time. Keep practicing, and remember there is an Anki deck available for free that recaps this lesson and schedules the practice for you. If you want people to practice with, I recommend joining this channel's Discord server, the world's biggest art learning experiment, where you can ask questions, get more challenges, and reinforce your learning amongst friends.